Hello, good day to you. My name is Michiel de Bonk. I work at Delft University of Technology and Significance. Today I will present to you a study we are doing to investigate to what extent we can expect to achieve the greenhouse gas emission targets using a simulation model for impact assessment. First, introduce you into the background of the study. Next, I will present the tool that we are using, the Harmony Tactical Freight Simulator. Then I will introduce the decarbonization scenarios we formulated and then discuss the results. First, about the background. The background to which we do this study is to fuel the debate about decarbonizing road freight transport. The discussion about this policy objective is going on for decades, but is becoming more and more urgent. It started with the European White Paper and in 1991, and in 2019 with the Green Deal was launched with a growth strategy for a climate neutral Europe. And currently the European Commission is working on a Fit for 55 package in which a concrete set of measures is formulated with which the Commission hopes to realize the reduction of greenhouse gas emissions back to the 1999 levels by 55%. So more and more ambitious climate goals are being translated into specific measures and plans for actions. Measures include like pricing, emission standards, phasing out of the internal combustion engine, and supporting measures. In order to see if we can meet the targets that are formulated, we need comprehensive impact assessments. However, the policy tools to do so, they are scarce. So the objective of this study is to simulate the impact of a comprehensive set of decarbonization measures to reduce the greenhouse gas emissions and to explore if we can actually reach these climate targets. The methodology that we are using is agent-based simulation. The geography of the study is an urban agglomeration in the Netherlands, the province of South Holland. We use a macroeconomic scenario for 2030, the high growth scenario. And in this first exploration, we are looking at optimistic scenarios for the impact of each measure. And the scope of the study, the emission calculations that are being simulated, is tank to wheel. Unfortunately, we cannot include also the well to wheel emissions in this study. But we are looking at a broad inventory of policy measures. The methodology we apply is a scenario-based study, and in a stepwise simulation, we introduce each individual impact to see the impact of each measure individually. Well, first, the tool that we are using. It's the Harmony Tactical Freight Simulator. I will give you a quick overview of this simulator. Well, the key design principles of this simulator is that it's evidence-based, so it's based on an extensive road freight data set. It's agent-based, so there's a lot of heterogeneity in city logistic behavior of producers, consumers, and carriers. The approach is also shipment-based for more behavioral realism, so a lot of decision-making is taking place at the shipment level. For instance, the planning of round tours or the type of vehicle that will be used. And long-term and daily logistic decisions are simulated in separate layers. So the simulator has three phases. Long-term decisions are being simulated in the shipment and parcel demand module. Daily decisions are simulated in the scheduling module. And in the scheduling module, the decisions are being simulated regarding tour formation, so the consolidation of shipments in a round tour, and also delivery time of each of the shipments. And then finally, there's a network module that simulates the route choices of each individual vehicle and does a disaggregate emission calculation. Well, the advantage of such a detailed simulator is the possibility to simulate impacts that are not generic, like parcel delivery is done by different types of vehicles compared to supermarket distribution, or the impact of a zero emission zone, it can be very locally. Therefore, a detailed simulator taking into account the different segments of city logistics that are behind road freight transport is necessary. Well, today I will present to you the working of the model just by a simple overview in 6 figures. So first of all, we have a synthetic firm population in the study area. Next, given this firm population, we can estimate the total demand for road freight transport. The model also simulates the part of the transport that takes place using distribution channels. So this illustration shows the total logistic flows between distribution centers in the study area. Round tours are being simulated. So this figure shows for one of the transport carriers in the area the simulated round tours that are planned for one day to do round tours of the collection and distribution of shipments. And once all these vehicle schedules are being simulated or being assigned to the network, you can also do emission calculations. This is visualized in this emission graph. And then finally, from all this data and all this simulated information, you can derive the necessary and detailed KPIs, such as CO2 emissions by a specific logistics segment. So this is a very quick overview of a very elaborate, detailed logistics simulation model. Now let's go to the case study, the decarbonization scenarios for road freight transport. Well, to prepare these scenarios for decarbonization, we made an inventory of measures from recent studies that have been done. Well, this slide shows a list of all these studies. Of course, Fit for 55 is an important study. We also used extensively the ITF study on the decarbonization of urban freight transport. And also important to mention is the study by Professor McKinnon from 2018, which was one of the first comprehensive studies into decarbonization of the logistics sector. Well, from this study, we clustered the measures along 4 topics, I should say: demand reduction, clean energy, energy efficiency, and logistic efficiency. And for the first implementation of a scenario, we assumed an optimistic impact. So we chose the upper bandwidth of the expected impacts of each measure. Well, how can we measure the implemented? How can we implement the policy measures into the simulation model? Well, to give you an idea, I want to explain to this these functionalities in the model for particular measures. First of all, we can adjust the unit prices or emission factors. These are like conventional model parameters in the model. So the emission factors that can be reduced as a result of fuel efficiency gains or improvement of the driving behavior, or the choice parameters in the logistic decision making. So if we assume a scenario with more efficient planning, we can assume more consolidation of shipments in round tours and effectively aim for a certain target of an increase in the load factor of vehicles. In addition, we make use of targeted expert-based transition scenarios that are specific to logistic segments. For instance, for the impact of a zero-emission zone. That way, we can take into account the characteristics for each segment. And the city distribution of supermarkets, they will respond in a different way to the distribution to zero-emission zones compared to small retailers that don't have the funding to buy their own zero-emission vehicle. So we also need hubs for small carriers without zero-emission vehicles. So this is an example of one of the transition scenarios. Another transition scenario we use for the penetration of alternative vehicle technologies, like the uptake of electric vehicles or hydrogen vehicles for heavy goods transport. And finally, we can also adjust the external demand scenario, including a model shift scenario for the reduction in demand. Well, here is a complete overview of all the measures in the 4 clusters. It's very much inspired on the previous decarbonization studies. We have set the assumptions based on these previous studies. One disclaimer, these assumptions, they are expert-based, so I'm not saying that these are hard facts. The point that I want to make, we can make our best guess here, and this best guess is made explicit, and in this case, as specific as possible. One of the next steps that we will do is test and run different and alternative assumptions for all these measures. Now, finally, the result. The result is summarized in this graph. It shows the gradual impact of each of the decarbonization measures. Large impacts can be expected from the clean energy scenarios, so the electrification of trucks in zero emission zones or hydrogen trucks. In addition, fuel efficiency can also add a great deal to reducing the impacts. So the reduction of emissions of the internal combustion engine itself, or improving the driving behavior. And the logistic efficiency scenarios, they have a modest impact. One disclaimer here, the order of the measures, it has impact on the absolute impact. So the figure can be misleading. So we can also play around with that a little bit if we want to make sure if indeed the logistic efficiency impact wouldn't be bigger if we would include it as a first step. The overall conclusion, to summarize, if we take optimistic estimates from literature, the policy objective is within reach. So here we also plotted the policy target of the Fit for 55 target for 2030. So to reduce the greenhouse gas emissions by 2030 to 55% of the levels of 1991. Another aspect I would like to take out is that the impacts, it can be very location specific, like the impact of a zero emission zone in the city center of Rotterdam. It leads to a very strong reduction in a particular area of the network. So in order to analyze all these phenomena, you need a disaggregate simulator. Finally, the conclusions and outlook. The goals for Fit for 55, they seem feasible. If we take rigorous measures, the impacts, they can be locally very diverse. So urban simulation models are needed to make a more reliable impact assessment for this. The impact assessment that we present here is based on optimistic assumptions, and in future work we will also develop alternative scenarios for realistic or more pessimistic scenarios. And finally, the type of study that we are doing here, it can also be used to track the progress to achieve decarbonization goals. Well, I thank you very much for your attention, and I look forward to the workshop to learn more about the opportunities and challenges to decarbonize road freight transport, and I'm sure that we can use your expert input to improve our assumptions. Thank you.